Hi guys, this is Miss Igo. Welcome to my classroom. Today I'm going to be talking about linear programming. Many problems in business, science, and economics involve finding the optimal value of a function, which we call the maximum or the minimum value, and linear programming is the process used to find these maximum and minimum values using linear inequalities. So if we look at an example like this one, the way that we can find the maximum and minimum values is by substituting in the corner points of the feasible region where the boundary lines intersect. So these corner points are going to help us find the maximum and minimum values. So this example asks us to find the maximum and minimum value of this function, z is equal to 5x plus 3y, for this region. So the first thing that we need to do is find the coordinates of these corner points. So if I look here at this point, I start at 0, 0, and I go to the right 1 and up 3. So the coordinates of that point is 1, 3. This one right here, I would go to the right 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6, 7, 8. So 4, 8. This would be 1, 2, 3, 4, 5, 6, 7, 8, and up 1, 2, 3, 4, 5, 6, 7. So we went to the right 8 and up 7. And then this last one, we know that this is 10, so this would be to the right 9 and up 1, 2, 3, 4. So those are the corner points of my regions. To find the maximum and minimum values of the function, all I need to do is plug those coordinates in to the function, and that's what I will do now. My function is z is equal to 5x plus 3y. So these coordinates, of course, are my x and my y's, and I'm just going to take each one. So let's start with the coordinate of 1, 3. And if I plug that into the function, z is equal to 5, I'm going to substitute 1 in for x plus 3 and substitute in 3 for y. And when I simplify that, 5 times 1 is 5. And 3 times 3 is 9, which gives me 14. So that's what I get whenever I plugged in the coordinates of 1, 3. And we want to do that with all of our coordinates. So I'm going to do it with 4, 8. Just exactly the same thing, only I'm going to put in 4 for x and 8 for y. And for this, I get 44. And then the 8, 7. Put 8 for x and 7 for y. And that gives me a total of 61. And then the last point is 9, 4. Again, I put in 9 for x and 4 for y. So when I look at the answers, once I plug in the values into the function, for each coordinate, each set of coordinates. The maximum value is 61, and that was found at 8, 7. And then the minimum value when I look at all of the solutions, I get 14 is the minimum, and that is at 1, 3. Now this example also asks us to find the maximum and minimum values of a function. The function is z is equal to x plus 2y. But this time it doesn't have the graph drawn out for us. So they give us the constraints or the inequalities that we need to graph first. So that's the first thing that we need to do. And we have these constraints. X plus y is less than or equal to 10. 3x plus 2y is greater than or equal to 6. X is greater than or equal to 0. And y is greater than or equal to 0. So I'm going to graph all of these in the same plane. This first one, I have x plus y is less than or equal to 10. If I were to think of this as an equation, x plus y is equal to 10, I could either graph this by using the intercepts. So when we're graphing by using the intercepts, if I were to plug in 0 for y, that tells me that x is 10. So on my x-axis, I would put a point on 10. And then if I were to go back in and put a 0 in for x, that would leave me with y equals 10. So on my y-axis, I would go up to 10 and put a dot and then connect those points. If you wanted to, you could rearrange this and get it into slope-intercept form and graph it that way. Either way, you'll get the same line. So I will connect those points using a solid line because it's the less than or equal to. So now we need to determine what side of the line to shade on. I could either get it in slope-intercept form and use a shortcut to determine which side to shade on, or I could just pick a test point. If I were to pick 0, 0 and plug this into the inequality, 0 for x and 0 for y, that would be 0 is less than or equal to 10. That is true, so that means everything under the line, everything on the same side as 0, 0 is true. So we know we would be shading under the line. So I'm going to put just a little bit of highlight on that side to remind me that's the side of the line that I would be shading on. Now to graph this second inequality, I'm going to get it in slope-intercept form. So again, you could graph it however you want to graph it. You could get it in slope-intercept form. You could find the x and the y intercepts. You could make a t-table. However you want to graph your line is fine. But just as a refresher, I'm going to get this in slope-intercept form. So to get this in slope-intercept form, I'm going to subtract 3x from both sides of the inequality. And that gives me 2y is greater than or equal to negative 3x plus 6. And then I divide everything in the inequality by 2. Now remember, when you're dealing with inequalities, if you're going to get your inequality in slope-intercept form and you want to use the shortcut to determine what side of the line you shade on, you need to make sure that if you multiply or divide everything in the inequality by a negative number, that you flip this inequality. Well, I'm not dividing by a negative, so I do not need to flip the inequality. So that leaves me with y is greater than or equal to a negative 3 over 2x plus 3. All right, so this is my equation in slope-intercept form, and That tells me that my slope is a -3/2 and my y-intercept is 3. We begin with our B, which is our y-intercept. And so on my y-axis, I'm going to go up to 3 and mark it there. And then I'm going to use my slope, rise over run. One of these needs to be negative, but not both. So if I do a -3 over +2, that means I would go down 3 and to the right 2. I could go up 3 and to the left 2. That would be part of the same line, but that's away from where I'm graphing. So I'm just using the one down 3 into the right 2. Again, this is greater than or equal to, so I will be connecting these with a solid line. And to use the shortcut to determine which side of the line we shade on, as long as it's in slope-intercept form and you followed the rules and flip the inequality when you need to, if our inequality says greater than, we shade above the line. If it were to say less than, we would shade below the line. So because this is greater than, we would be shading above this line, which is in this direction. Now the last two constraints are x is greater than or equal to 0 and y is greater than or equal to 0. So this is going to be on our x-axis, just like any horizontal or vertical line. If it's just an x or just a y, we graph it by saying x at 0. So on our x at 0. And then if you have watched my other videos and you know my shortcut for Hoy-Vux, the Vux tells me that it's a vertical line going through x at 0. So we would draw a vertical line this direction. X is greater than 0, so that means we would be shading everything that is greater than 0 or to the right of 0, so this direction. Then for y equals 0, or y is greater than or equal to 0, to graph that line, y equals 0, we cross through y at 0, and Hoy tells us it's going to be a horizontal line. So here is y at 0, so we're going to draw a horizontal line through y at 0. And again, we need to determine where to shade. So since y is greater than 0, here's y. Greater than 0 would be above that horizontal line. Less than 0 would be below, so we're shading above this horizontal line. So the parts that overlap in all of those inequalities is all of this inside here. Now that we have graphed our region, we want to find the coordinates of the points where they intersect. So this first intersection is at 0, 1, 2, 3. This intersection is at 0, 10. This intersection is at 2, 0. And this intersection is at 10, 0. And just like before, we're going to take those values and put them in this function. So if we plug it into the first function, z is equal to, I'm putting in 0 for x, plus 2 times 3 for y. And when I simplify that, I get 6. And then when I put in 0, 10, 0 for x, plus 2 times 10 for y, that would be 20. In the next one, we have 2 for x and 0 for y. Well, 2 times 0 is 0, so 2 plus 0 would just be 2. And in the last one, we get 10 for x, and we're plugging in 0 for y, so 10 plus 0 is 10. So the 20 would be our maximum, and 2 would be our minimum. So to answer the question, find the maximum and minimum values of the function, we could say that the maximum value is 20, and it was found at 0, 10. And then the minimum value is 2, and it was found at 2, 0. I hope you enjoyed this video. If it helped you, then please share it with your classmates and make sure to subscribe to my channel. Thank you for watching.